Hi guys, the purpose of these videos is just basically to explain how I understand computer programming. I know for I think at least half of us they jump right into the lectures and they use very technical language, and if you haven't had like previous programming experience, it's sometimes a bit hard to follow, but yeah, it's my favorite subject so far. I haven't done programming before this year, so like the way I explain it to myself would probably be understandable by others in a similar situation. But yeah, I'm just sharing how I understand it because I have been able to follow quite well and have been getting basically full marks for my quizzes so far. So I think I more or less know what I'm doing. So yeah, I'm just gonna basically explain everything, and I'm working from the notes that I made and sent on the groups. If you don't have it, I can just send it to you. So yeah, I'm gonna start from the beginning, from the notes I made. So the first one were parts of a computer. It's just more theory, but I think, yeah, I'm just gonna go through everything so there's nothing to miss. So just gonna change the color. So basically, I'm just going to make 3 parts. There's input, so whatever the user puts into input, and you get output. And then there's something going on in the computer. So input is something that you put into the computer. So that would be using your keyboard and your mouse. And that's basically anything that you type in. And then your output is everything that the screen displays, so everything it prints on the screen. So you call this your input unit. Input unit, so that's the keyboard and mouse, and the output unit could be a output unit, could be your screen or your printer or whatever you use to output the information. So this is just basic theory. Now inside this computer there is a few things that we need to know. So there's a CPU, an ALU, RAM, and some secondary storage unit, a secondary storage unit. So basically what these things do, this is the random access memory. So it's in the name, it's just rapid access, low capacity memory. It's like in a tutor session, someone explained it as being a small warehouse, and then this being like a large warehouse. So it's long-term high capacity storage. You just need to know, you don't really need to know exactly what these things are, it's just basic background. And the CPU is like the brain of the computer. It's where it thinks about what's happening. So it's a central processing unit. And the ALU is the arithmetic logic unit. So it performs all the calculations and logic decisions, and it's actually implemented as part of the CPU. So that's it for that part. Some additional background is just how a computer works. So your computer doesn't really understand human language, so it only understands it only understands zeros and ones, and we call this binary. Basically zeros and ones, they have to do with current flowing through a wire or not, or voltages flowing through a current, and then they store it as a 1 or a 0. And from these combinations of zeros and ones, it can translate that into code that we understand and things like that. But it isn't that important to know it, but that's just where it comes from. So what happens? So in a computer, you give it instructions. This computer transforms it into zeros and ones. And then it transforms into a program that is ready to run. So this is basically what happens, what we've been doing in code blocks so far. So we give it instructions, something called the compiler transforms these instructions into zeros and ones so that the computer can understand them, and then this is transformed into a program that we can run. So just to say what these are called, this is called the program source code. So this is that's just what you call it, the program source code. And then the compiler transforms it into, we call it the program executable. And you can see, because everything's always .exe, so it's the executable. So we usually write it in formalized language, so in C. That's what we've been using. And it's just something that we could pass to the compiler that transforms so the computer hardware can understand it. So the source code we can also call the executable. More theory. We use C programming language that is human readable but specific. And when the computer executes these instructions, we say, so when a program is executing the instructions that we gave it, we say that the program is running or it is executing. And the formal recipe or procedure that we use for calculations, or something that we use to solve a problem, the method that we use to solve any problem is called an algorithm. And a program implements an algorithm. So this is just some terminology. Some other things I want to say, I'm going to be referring to some characters that we use. So these are called braces. These are called parentheses. I don't know how to anyway, and these are called brackets. So, I might also call these curly brackets and square brackets, and just, I don't know, but these are the correct terms there for them. And so let's move on to types of programming languages. I think they've asked this before. So types of programming languages. One, you get machine languages, then you get assembly languages, and then you get high-level languages. This is just theory. They have asked before, I think. So machine languages are strings of numbers giving the machine specific instructions. So these could be like I don't know, any random numbers, but this makes no sense, but the computer understands what's going on. So this is like the most basic of language that the computer understands. This is not the type of code that we write. Then you get the assembly language. That is sort of an intermediate between what the machine understands and what we understand. So this would be abbreviations that we use to represent operations. The example that they used in the lecture was, I think, load, base, pay. So the computer is given instructions, and then it converts to that, and then does whatever it is. So high-level languages is coding similar to everyday English. C programming language is a high-level language. So this is then translated using a compiler so the computer can understand. So high-level languages are something that we understand. So we can say, this is the example they used, gross pay equals base pay plus overtime pay. So the computer itself wouldn't know what on earth you're trying to tell it, because they don't even understand numbers. But if it's converted from this that we understand, I mean, we can understand this. Something is equal to something plus something. Okay, it's translated to an action that the computer has to do. But what action does it have to do? Well, it has to do something specific that only the computer understands. So yeah, that is what the different programming languages are. So a typical C program development environment has 3 parts, and these we have to know. So the parts of C is a program development environment, the language, and what on earth? Okay, the language and the C standard library. Library. So I think this is basically the IDE. So IDE is the platform you use to write your code. Because I mean, you can't use a Word document to write code. You can use Excel. Can you use Word? I don't know if you can use Word. I don't think so. I don't know how. But you can use Excel to write code. I think industrial students are doing that. And you can use, I can't remember the other, I think Eclipse is another IDE. We use Code Blocks. But our tests are, for our tests we use Code Runner, which they put into Sunlearn. Okay, then it's the language and the C standard library, which is, I think, the header files. So what's important to know, which they also have asked before, is the 6 phases of programming. And these are edit, pre-process, compile, link, load, and execute. So editing is the thing that you do. You're in C. Oh no, you're in C. You're in Code Blocks, and you're just writing a bunch of code, and you're saving it as a file that is .c. So when you press build, it pre-processes the things that you wrote, compiles them, and links them to object files and things like that, and links them into a type of program, then loads the program and executes it. So that is basically the theory that we have to know for now. In the next video, I'll start with the hello world action, so printing text in C.